session. This is the second in our series of videos on probability and statistics of the West African Examination Council Senior Secondary School Mathematics Examination for Liberia schools. In this video, we'll specifically focus on probability and on the objectives of applying the addition and counting principles and the multiplication and counting principles to compute probability of certain events. We'll begin by going over a few theoretical information. We already talked about mutually exclusive events. These are events that can not overlap, can happen together. Okay. And then we'll talk about events that are not mutually exclusive, which we can apply these basic rules on it. This is the addition rule. Okay. And then we'll talk about an independent event. And two events are independent if the occurrence of one does not affect the occurrence of the other one. All right. So we have that stated over here. So normally for independent events is when we associate that when we pick from a box with replacement. So you pick it up and you put it back before you make the next attempt to pick up an item. Okay? Events in which, situations in which you pick without replacements are considered to be dependent events because the occurrence of one impacts on the occurrence of the other event. All right. So when the events are independent, then we can use this computation for that. So we say the probability of A, given that B occurred, is just the probability of A, because the occurrence of B does not affect the occurrence of A. Likewise, the probability of B, given that A has occurred, is just the probability of B, because the occurrence of A has absolutely no impact on the possibility of B occurring. Okay? Now let's see what happens when the events are dependent. For dependent event, we compute it this way because we have to take into consideration. So the probability of those two events, A and B, occurring has to take into consideration that the other one has happened. So the probability of A and B will be equal to the probability of A given that times the probability of B given that A, and likewise the other way around. So here, one event can impact on the other event. It says here that the probability that Mr. Cheeseman passes English on an examination is 2/3. So let's use E for the Mr. Cheeseman passing English. So the probability of that event E is 2/3. That's one of the most important things to do when you're reading this kind of problem. So we'll use M for math. So the probability of him passing math would be 4/9. If the probability of him passing either subject, now when you see this either, that means the probability of him passing what? English or math. This is how we represent it. And so this then becomes amenable to the addition rule, addition counting principle, now, of probabilities. So then, if the probability of him passing either subject is 4/5, so that means it's 4/5. What I want us to find is the probability that he passed both. Probability that he passed both, that means the probability that he passed what? English. And he also passed what? Math. That's what we don't know. So we can proceed by using the addition counting rule. Yeah, we'll say the probability of A or B. In fact, in this case, let's be specific. We'll say the probability of what? Probability of E or, and then rewrite it so that it's clearly understood. The probability of E or M is given by the probability of E plus the probability of M minus the probability of what? E and M. So that's what we have. So what we're going to do is a substitute. The probability of E or M is basically what? 4/5. So we have 4/5 equal. The probability of E is what? 2/3 plus. The probability of M is 4/9, and what we want to know is what is missing. So we're going to do simple equation solving here, and then we're going to proceed to getting our answer. So we're going to do that on the next page. So let's proceed there. So let's begin. Let's write it out. So we started with 4/5 equals 2/3 plus 4/9 minus the probability of M and what? E. So we're going to do some basic math here. We can we'll just get rid of this. But let's take, for example, let's come here and find the least common denominator here. That's going to be 9. That's going to be 3 times 2. That's going to be 6. 6 plus 4. That's going to be what? 6 plus 4. Oh, I'm already adding. So basically, we're going to have a least common denominator of 9. 9 divided by 3 is 3. 3 times 2 is 6. Plus 9 divided by 9 is 1. 1 plus 4 is 4. Minus the probability of M and what? E. So we're going to have 4/5 equals to what? 10/9 minus the probability of what? M and E. So let's do this. We're going to subtract this from both sides. So we're going to have 4/5 minus 10/9 to be equal to negative the probability of M and what? E. So now let's come over here and see how can we do this. First of all, let's just take this problem up there and do 4 over 5 minus 10 over what? 9. Our least common denominator will be 45. 5 into 45 is 9. 4 times 9 is 36. Minus 5 into 9. 9 to 45 is 5. 5 times 10 is 50. When we subtract here, we're going to have negative what? 14 what? Negative 14 over 45. So what we have here now is that we're going to have a negative 14 over 45 is equal to the probability, negative the probability of M and what? E. So we'll divide both sides by negative, so we're going to get the probability of M, and the negative will cancel when we divide it. Probability of M and E is going to be equal to 14 over 45. The probability of M and E, probability of M and E will just be equal to 14 over what? 45. Remember this negative and that negative cancel, so they go out. Okay, good. So now this is taken from WAEC LIberia 2006, paper 2, section B, the essay section, the one that seems to be a challenge. This was just a part of the problem. So they have the following grades here that was given on by some students. So what's the probability that a student selected at random will score at most 26? So at most 26. So the first thing we want to do with these scores is to arrange them in order so that we don't have to worry about finding at least, and then we can do the interpretation. So I've done that already. So I'm just going to list them over here. That's 32. As you can see, we do not have a 33 over there. 32, how many 32s do we have? 3. Make sure when you do this, you can check, you can verify. 10 is up there. 22, have 1, 22 is over there. 25, have 1, 2, 3, 25, done. 26, I have 1, 2, 3, 4, 26. So do I have 426 over here? 426. So I kind of messed up here. I need to expand this. That's the good thing about doing this. When you go back to double check. 26, 26, and then I have what? 32, 32, 32, and then 40. So I have 426. I've done that. So then I have 32. I have how many of 32? 1, 2, 3, 32. I have 3, and then I have a 40. So they're all gone, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I have a total of 13. So that means the number of elements in my sample space is 13. Now, how many of these numbers here is at most 26? At most. So if A is that event of what? At most 26, let's list the set for A. And then we'll find the number of elements in A. At most 26 means it does not exceed 26. That means it reaches up to 26. So I have 10, 22, 25, 25, 25, 3, 25, and 4, 26. 1, 2, 3, 4, 5, 6, 7, 8, 9. So So that means the number of elements here in A is equal to what? 9. So then how do we find the probability? Very simple. So the probability here of A, let me see if I have a space on the next slide so I can just do it over there instead of kind of squeezing it over there. All right, okay, so I don't, so I'll go back and just see if I can fit it in there. So the probability of A will be given by the number of elements in A divided by the number of elements in the sample space. It says here the probability that a man lived 10 more years is 1/4. So let's say the probability of a man living for an additional 10 more years is what? 1/4. And the probability of his wife will live for additional 10 more years, so we'll use W for wife, is going to be what? 1/3. Find the probability that both will live in 10 years, will be alive in 10 years. At least one will be alive in 10 years. Neither will be alive in 10 years. So let's proceed. So let's do the first part of this problem. Probability that the man and wife will live. Now the life of a man here does not affect the life of the woman. Really? So we're going to say the probability of what? M times the probability of what? W. Yeah, like independent event. So that means it's going to be what? Probability of the man is what? 1/4 times the probability of a woman living for 10 additional years is 1/3. That will be 1 over what? 12. So let's go to the next one. It says at least one will live in 10 years. What I would do is that I would do C first. Neither will be alive in 10 years. So let's go. Probability. Neither. So that would be probability of what? Not M times the probability of what? Not. Okay, let me make this very clear so that you see it. So that will be the probability of not M times the probability of what? Not W. So like I said, I'm doing C first. So then, let's see, how do we find the probability of not W? So this is going to be 1 minus the probability of M times, parentheses again, 1 minus the probability of what? W. So this is going to be 1 minus the probability of man was 1/4 times the probability for a woman was 1 minus what? 1/3. So basically what we're going to have here is going to be 3/4 times 2/3. 3/4 times 2/3. And so what is that going to give us? That's going to give us like, this is cancel. This is going to give us 2 over 4. We can simplify that to be what? 1/2. So the probability that neither will be alive is going to be 50% chance. That's that. So now let's go to B. B says, what's the probability? At least 1. So probability of at least 1. We'll use the concept of complement will be equal to 1 minus the probability will be what? None at life. You know, so and then that's the case, that's the key for doing this problem over. So the probability that neither of them will be alive is half, so it will be 1 minus 1/2, and that answer will give us just basically what? 1/2. So that was the whole trick about doing that first and then proceeding to do the next one. Okay, so let's begin in this problem by first identifying the elements in each of these sets. Okay, good. And some of the ones that are in this problem. So good. So let's find U. The universal set would be those elements 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry. 5, 6, 7, 8, 9, 10. And then let's go for those elements A in set A. Now, A will be factors of 20 that are within this universal set. So what are the factors of 20 on this universal set? Those are the numbers that can divide 20. That would be 1, 2, 4, 5, and 10. Then we have B. B would be multiples of 5 that are on this universal set. The multiples of 5 on this universal set will just be 5 and 10. Then we have C. What is C? C will be the multiples of 4 on this universal set. So we start with 4, count by 4, 4, 8. So those are 2. So now, in this problem here, they wanted us to find the probability of A intercept B. We could use formulas, but better still, we have every information here. Let's see if we can do that. Let's see if we can find A intercept what? B. So what does A and B have in common? Looking here, they have 5 and 10 in common. So it's 5 and what? 10. So the number of elements in A intercept B will be 2. So to find the probability here of A intercept B will be the number of elements in A intercept B divided by the number of elements in the sample space or in the universal set. So we know the number of elements in this universal set is what? 10. Okay? And we know this to be 2. So we're going to come back to that later on in the next slide. So let's go. Next one we're going to talk about will be B union C. Let's find B union what? C. So what are those elements that are in both B or C? So those are just going to be what? 4, 5, 8, and 10. Yeah, they are either in B or C. So the number of elements in B union C is actually 4, correct? Good. And lastly, let's look for A intercept B intercept C. So I'm talking about A intercept B intercept C. So let's see. What will they have in common? 1, no. There's 10 in there, there's 5 in there, but there's no 10 in here. So they have absolutely nothing in common. So basically, this is equal to the empty set. So the number of elements in A intercept B intercept C will be 0. So let's proceed now to computing what we have here. So the first thing we have to do here was number of elements in A intercept B intercept A intercept B intercept C. Sorry, A intercept B. Okay. So A intercept B. So will be the number of elements in A intercept B or the number of elements in the sample space. The number of elements in the sample space was 10. I'm going to set them up like this and go back. Next one was probability of what? B union what? C. That would be the number of elements in B union C over the number of elements in the universal set. I use S over here. That's the same thing. Number of elements in S, number of elements in the universal set will be equal. And then in C, we're supposed to find the probability of A intercept B intercept C. This is clear that the number of elements in A intercept B intercept C divided by elements in the universal set is going to be 0 over what? 10, and so the answer is what? 0. The intersection was 0. So let's go back and find the number of elements in A intercept B. The number of elements in A intercept B was 2, and for B union C was 4. A intercept B was what? 2, and for this it was 4 over what? 10. So we can simplify it, we're going to have 1 over what? 5. We simplify it, we divide by 2, we'll have 2 over what? 5. So our answer will be 1/5, 2/5, and 0. That a box contains 20 identical balls. Okay, 8 of them are red, so we'll say red, the number of red is going to be 8. And 7 are white, the number of white will be 7. And the rest will be black. So number of what? Black, I think that's going to be 5 because 7 and 8 will be 15. Take that from 20, that will be 5. So what I want us to do here is to find they want us to, without replacement. So this thing has been done without replacement. So the events here are dependent. So we get dependent events. So because we are dealing with unreplacement events, what do they want us to find? Is it find the probability that they are both, when you pick 2 balls, that probability that both will be what? Red and red, or black, sorry, white and white, yeah, black, that's it, let's go in the order here. White and white, or probability of black and black. Now, so basically what we have is a combination of the multiplication counting principle and the addition counting principle. The addition counting principle would be the OR, that puts our plus in it. So the multiplication counting principle for dependent event goes like this. That's going to be the probability of R times the probability of R, given that R has occurred, probability of W times the probability of W, given that W has occurred, plus the probability of B, black, times the probability of black, given that black has occurred. So we can just plug all those probabilities. We're going to be very careful. So first of all, what's the probability of picking a red ball in the beginning? Now you have 20 in total. The number of red when you begin to pick the first time will be 8. So after you have picked, that means the number of balls reduced to 19 and the number of red balls reduces to 7. Okay? Alright, reduces to 7. Next one, white. How many white balls do we have initially? 7. And because you are picking for the first time, 20. Now when you are picking the second time, you have picked a white ball, so that's going to affect the chance of picking a white again. But the number of white balls, you took it out, you did not put it back, has been reduced to 6. The total number of balls in there has been reduced to 19. And then for black, how many black balls do we have? 5. So when you pick the first time, it's going to be 5 over 20. You take it out, you don't put it back. So the number of black balls have been reduced, and the total number here has been reduced to what? 19. So we compute all of these things here. So we're going to have 56 here over 380. We'll do the multiplication. In fact, I'm going to just do this on the next slide. So I'll have 56 over 380 plus 42 over 380 plus 20 over what? 380. And we could perform all of these things. We add up all those numbers on top. We're going to have 118 over what? 380. And after we simplify, we're going to have 59 over what? Let me make sure of that. 59 over, let me divide this quickly. I don't want to give you a wrong division. I think I have something here wrong. So it's 118 divided by 59 over 190. 59 over 190. Yeah. So it's 59 over 190. So that's the probability of these events happening. Follow us on Twitter at our Twitter handle, LIberia. We also are on YouTube. As you can see, you can subscribe to our YouTube channel. And don't forget to send us your feedback to LIberia@gmail.com. And we appreciate your contributions. We want to expand our services. Thank you very much.